Have you ever wondered why stars twinkle? As you gaze up into the night sky, have you ever found yourself pondering this question? Today, we're going to embark on a scientific journey. A journey that traverses the vast expanse of the cosmos, delving into the heart of celestial bodies and the atmospheric forces at play right here on Earth. So buckle up, space enthusiasts and curious minds alike, for we are about to unravel the mystery behind this fascinating phenomenon. This video will unravel the mystery behind this fascinating phenomenon. Stars, those celestial bodies that light up the night sky, are more than just beautiful. They're ancient, they're distant, and they're incredibly powerful. Each one is a glowing sphere of hot, dense gas, churning and roiling millions of miles away. Stars are the backbone of the universe, the factories where all elements heavier than helium are forged. They're the cosmic engines that power galaxies and the beacons that guided sailors across vast oceans in the days of yore. They're the inspiration for countless myths, legends and stories, the muses of poets and the subjects of countless songs and works of art. Stars are also our connection to the cosmos. Through them, we learn about the universe beyond our planet. They are our celestial timekeepers, marking the passing of seasons and the progression of years. They have been crucial in helping us understand our place in the cosmos, the nature of the universe, and even the laws of physics themselves. But these celestial luminaries are not static. They're dynamic, changing entities full of energy and mystery. Among their many intriguing behaviors is a phenomenon that's fascinated humans since time immemorial: their twinkling. A star's twinkle, or stellar scintillation as it's scientifically known, is a captivating sight, one that's inspired countless pieces of art and literature. But the stars don't just shine, they twinkle. Let's delve into why. Before we dive into the why, we need to understand what twinkling is. Known scientifically as stellar scintillation, twinkling is a captivating spectacle that has been a part of our night sky for as long as we can remember. But what exactly is it? In essence, twinkling is the apparent change in a star's brightness or position, as observed from Earth. The starlight we see has traveled unfathomable distances across the universe, and just as it's about to complete its journey, it encounters the Earth's atmosphere. Our atmosphere, a turbulent sea of air, bends and refracts this starlight, making it dance and shimmer in our eyes. This is what gives us the effect of a star twinkling. It's not the star itself changing or moving, but the bending and scattering of its light as it passes through our atmosphere. Now that we comprehend what twinkling is, it's time to uncover why it happens. The twinkling of stars is actually due to our Earth's atmosphere. Yes, you heard it right. Our Earth's atmosphere is the unsung hero behind this celestial spectacle. But how does this happen? Let's dive into it. Imagine the light from a distant star embarking on a journey across the vast expanse of space. It travels in a straight line, uninterrupted, for billions of miles. But as it nears its destination, our Earth, it encounters the atmosphere. This is where the magic begins. You see, our atmosphere isn't uniform. It's a vibrant, ever-changing mix of gases, dust, and varying temperatures. This chaotic mixture does not sit still. It swirls and churns, creating what we call atmospheric turbulence. As the starlight passes through our atmosphere, it doesn't continue on a straight path. Instead, it bends, refracts, and shifts. This is due to the different densities and temperatures it encounters in the atmosphere. This bending and shifting of light is known as atmospheric refraction. Now here's the thing. This refraction isn't consistent, it's constantly changing as the atmospheric conditions change. One moment, the light may bend one way, the next moment another. This rapid, erratic shifting of light is what we perceive as twinkling. But there's more. The atmosphere also acts as a prism, scattering the starlight into various colors. This scattering is more pronounced for light that travels a longer path through the atmosphere. That's why stars closer to the horizon often appear to twinkle more and display more colors. This phenomenon, the twinkling of stars, has a fancy scientific name: astronomical scintillation. It's a beautiful result of the interaction between starlight and our dynamic atmosphere. So while stars are the bright spots in our night sky, it's our Earth's atmosphere that creates the mesmerizing twinkling effect. So it's actually our atmosphere that is the star of this twinkling show. But there's more to this story. The distance of stars also plays a role in their twinkling. Let's delve into the role of distance, shall we? The distance of stars from our planet isn't just about light years and space travel. It has a direct impact on how we perceive their shimmering light. Stars that are farther away from us appear to twinkle more. But why is that? As you might recall, twinkling is caused by the bending and scattering of starlight as it passes through our atmosphere. Now consider a star that's further away. The light from this distant celestial body has to pass through more of our atmosphere to reach us. That means it encounters more air particles, more turbulence, and more opportunities for its path to be bent and scattered. As a result, we see more twinkling. Think of it like walking through a crowded room. If you only have to cross a small room, you might be able to get to the other side without bumping into anyone. But if you have to cross a large banquet hall filled with people, you're more likely to get jostled and redirected along the way. It's the same with starlight. The greater the distance it has to cover, the more it gets jostled by our atmosphere. And the more it gets jostled, the more it twinkles. So next time you look up at a star-filled sky, remember that not all stars are created equal. Some are closer to us, while others are light years away. But regardless of their distance, each star has its own unique twinkle. A twinkle that has journeyed across vast cosmic distances, braved the turbulence of our atmosphere, and finally reached your eyes. Each twinkle is a testament to the star's epic journey and the incredible distances involved in space. And each twinkle is a reminder of our place in the cosmos, a tiny planet in a vast universe, witnessing the distant light of stars. So, the farther the star, the more it twinkles. So, we've taken a journey from our night sky to the stars. In this exploration, we've unraveled the mysteries behind the twinkling of stars, those tiny dots of light that have captured our imagination for millennia. We've learned that the twinkling or stellar scintillation isn't due to the stars themselves, but rather an interplay of light in the Earth's atmosphere. We started off by understanding what stars are, these massive, glowing balls of gas, mostly hydrogen and helium, undergoing nuclear fusion. Their light travels millions and sometimes billions of miles to reach us, a journey that is far from straightforward. We then delved into the concept of twinkling. This phenomenon, as we discovered, is not a characteristic of the stars themselves, but a result of their light passing through the Earth's atmosphere. Our atmosphere, a protective layer of gases, isn't uniform but is rather a turbulent, ever-moving sea of air pockets, each with different densities and temperatures. This turbulence causes the starlight to refract, or bend, as it passes through these varying air pockets, causing the light to shift direction and speed. This continuous shift, as the light travels through different layers, causes the stars to appear as if they're twinkling from our perspective on Earth. We also discussed the role of distance in this twinkling effect. Stars, despite appearing close to each other in the night sky, are actually staggeringly far apart. The further away a star is, the more atmosphere its light has to pass through, and thus, the more it appears to twinkle. So, the twinkling of stars is not a cosmic dance as many of us might have imagined, but rather a terrestrial ballet of light and atmosphere, a phenomena rooted in the laws of physics. Next time you look up at the twinkling stars, you'll know the science behind their dance. Keep looking up and keep wondering.